Toyota uses THUMS in many ways, but one way I can speak to is within the Collaborative Safety Research Center. We're able to partner with other OEMs and suppliers to really try to take the injury mechanisms we're seeing within these accident reconstructions and apply them to future vehicle developments.
So for a last pre-topic is on real-world crashes and applications of THUMS. And Jesse Bueller and Dr. Joel Stitzel from Wake Forest. Jesse, please go ahead.
Thank you. Thank you, Chuck. So I'm Jesse Bueller. I'm with Toyota, and I have the pleasure to introduce the real-world crash injury reconstruction using THUMS, which is a CSRC project. We're working on this in collaboration with our research partner, Wake Forest. So as Robert mentioned, THUMS research is being used to improve the safety of race cars for race car drivers. This project that I'll introduce is using to improve vehicle safety for vehicle occupants outside the racetrack. What we're doing in this project is we're combining finite element vehicle models and the THUMS human body model and trying to recreate real-world crashes. Our real-world crashes come from Siren, which is a national database. And the advantage of using Siren is it has very detailed data. So an example of this kind of data is there'll be an accident scene investigation, and you can see vehicle deformations. The detailed occupant injury and medical imaging data is recorded. And then using all of this data, we tried to recreate the crash event using computer simulation. So in this case, once the vehicle deformations are decided, we reintroduce THUMS to the simulation, and we can start to see the underlying injury mechanisms that are taking place, much like Robert explained in the NASCAR model. So we've just completed, I should say the Wake Forest Injury Biomechanics team just completed a side impact crash reconstruction, and I'll turn it over to Dr. Joel Stitzel to explain the methodology used by his team.
Thanks. Thanks, Jesse. So we're really fortunate at Wake Forest to be a part of the Crash Injury Research and Engineering Network, and that's the Siren that Jesse referred to. And that's a network of trauma centers. And of course, if you're injured in a car crash, where you generally go first is to a trauma center if you're badly injured. And the nature of Siren is that we enroll kind of the worst injured patients. We enroll people who have used their safety systems generally, and they're in the types of crashes that we all get into. But we want to learn something about how those safety systems and vehicles did, protecting them in those injuries. The first crash mode that we're looking at, and we can go ahead and play this and loop it, is side impact. So we have a long-term plan to look at many different crash modes. But the first one is actually one of the toughest to protect people against, is a side impact crash. And we are basically reconstructing real-world crashes. So for this particular case, this is an occupant who came to our trauma center, went through the full workup, received a lot of injuries as a result of this crash. We're modeling the vehicle as closely as we can, and the vehicle that's hitting the vehicle as closely as we can. And the THUMS is very close to the same size and shape and anatomy as our case occupant. And we're very quantitative about this. We want to get engineering data out of it that we can use to improve vehicle safety. So we're correlating things like our crash investigator is excellent, gets measurements on the side of the vehicle here, which we have virtual measurements, which we do to know the dynamic crush and the static crush in this crash. But I think the key is that we're putting the THUMS model into the simulation and looking at the interaction of THUMS with interior vehicle components to see how the injuries the person sustained were received. And we've done additional things with THUMS. We've sort of added the ability within THUMS to look at specific parts of the anatomy, to look at loads in specific locations, relate particular parts of the anatomy to the injuries that were sustained in our crash. And an example of this, when someone comes into the trauma center, generally they're badly injured, they're trying to figure out what injuries they have. They go in, they get a CT scan. And that CT scan is basically from head to toe. And it gives you detail on for instance, the lung injuries, the soft tissue injuries in the chest. This is a pneumothorax and a lot of pulmonary contusion. A splenic injury. Splenic injuries can be very dangerous. You can bleed. You can bleed to death from a splenic injury. And that's a splenic injury. And also brain injuries. Internal deformations of the brain can cause brain injury that we can see in a CT scan or in an MRI scan. And the goal with THUMS, as you can kind of see just looking at this, is to be able to take these metrics, these things that we've developed within the THUMS model, and try to correlate them to the real-world injury. So this is a three-dimensional reconstruction of the injury that our patient from that siren case sustained. And these are some of the metrics that we're looking at, the deformation of the lung, the deformation of the spleen. And correlating these volumes together, we can start to understand these soft tissue injuries a lot in the same way that you just saw with the rib fractures. That's really important to do for these injuries because these injuries are the ones that ultimately kill you, the injuries where you bleed. So with that, I'll turn it back over to Jesse.
Thank you. So one of the keys is then translating this research into the next step. So we're currently studying the mechanisms of injury from the impact that we just presented. And then our next step is to apply the newest technology restraints to this vehicle and see how the injury outcomes are changed. And the reason is that this is a relatively older vehicle. It doesn't have all of the latest technology that we would sell with a vehicle that we could sell today. So we want to update that vehicle with the newest restraints. Then we want to see what gaps remain. So even with the newest restraints, where do we still see the ability to improve safety for future vehicle designs? And then ultimately, our goal is to partner with suppliers and implement those safety improvements into future vehicles. So thank you. I guess I should invite you to come back to the back of the room after this, I guess immediately following this. We're following Chuck's presentation here, and we'd like to talk with you some more. Thank you.